Hello everyone and welcome to my presentation. Today I'm going to share an interesting topic about network computers, focusing on how they vary in our daily lives and how their structures are built. Before we begin, let me introduce myself. My name is Putudea Krisna Pratnyotami. I am student of the Educational Technology 2025 with my student ID number is 25 11 02 10 13. Now, before we look at the PowerPoint slides, please take a look at this mind map on the screen. To make it easier for all of us, I have simplified the entire module into 6 main branches, starting from the core concept, network scale, architecture, core hardware, advanced devices, and finally topologies. Let's explore them one by one. Let's start with the definition. A computer network is simply when two or more devices are connected together so they can talk to each other and share things. There are three main benefits we see every day. First is resource sharing. For example, at home, if your family only has one printer, everyone can use that same printer through Wi Fi. You don't need to buy a printer for every single person, which saves a lot of money. Second is communication. Bridges physical distance to facilitate instant, real-time data exchange and digital collaboration. Think about sending messages on WhatsApp or email. Your data travels instantly across any distance. And third is data security. Protects valuable institutional assets through centralized storage, control access, and reliable backup systems. It's like when we save our photos on Google Drive, our file stays safe even if our smartphone gets broken or lost. Next, let's look how networks change based on distance. First, we have LAN or local area network. This is small network that covers just one room or one building, usually up to 100 meters. If we scale it up to cover a whole city, it becomes a MEM or Metropolitan Area Network, covering 10 to 15 kilometers. A great example is the network of BPD Bali ATM machines across Singaraja City. All the ATM machines are linked together so they can update your balance instantly. A perfect example is the Wi-Fi network inside your house or the computer network inside our campus computer lab. Now, if the network connects different countries or continents, we call it WAN or Wide Area Network. And the biggest scale of all is the Internet. It is the massive global connection of all networks on Earth. We can use it every day for scrolling TikTok, searching Google, or watching YouTube. A simple example is the network used by global apps like Shopee or mobile banking, where the main data center is overseas, but we can still access it instantly from Indonesia. Moving on to network architecture, which is how computers split their jobs. The first model is client server. This is a centralized system. Think of it like ordering food at a restaurant. We ask customers or the clients who ask for food, and the kitchen is the server that provides it. If the kitchen closes, nobody eats. A real example is our campus website. When the campus server is down, no student can open the page or fill out their KRS. The second model is peer-to-peer or P2P. This is a decentralized system where all devices are equal, like friends sharing notes. There is no boss or central server here. A very simple example is when you send a photo or video to your friend's phone using Bluetooth or share it. Both phones connect directly to each other without needing any other computer. To build these networks, we need physical hardware. First is the NIC. Simply put, this is the network cable slot or port that you see on the side of your laptop or PC. Second is hub, which is a basic connecting device. Think of a hub like a standard multi-plug power strip in your bedroom. It just splits the path so multiple devices can plug in. Third is a switch, which is a smart version of a hub. Imagine a hub is like a person shooting a message to everyone in a room, but a switch is like a smart mailman. It reads the destination address and delivers the data only to the specific computer that needs it, keeping the network fast. Now, let's look at the advanced devices on this slide, which are the router and access point. First, we have the router. Think of router as a bridge that connects to completely different islands like Bali and Java. Its job is to connect our local home network to the outside internet provider. Without router, our computers can only talk to each other inside the room, but we cannot open Google. Second is the access point. This is the device that creates the wireless Wi-Fi signal. A real example on campus, when you look up the ceiling in the hallway and see a small white round box, that is the access point. It broadcasts the free Wi-Fi to your phone, but that access point must be connected by a cable to hidden box in the admin office called the router to connect it to the global internet. Next, let's discuss network topologies, which is the physical layout of the cables. First is star topology, the most popular layout today. It looks like a bicycle wheel. The switch is in the middle and all computers connect to it. The benefit is simple. If my laptop cable breaks, everyone else can still use the internet safely. Second is bus topology. This is an old model where all computers are lined up along a single main cable. The problem is like a main water pipe on the street. If the middle pipe bursts or breaks, the water stops for every single house on that street, meaning the whole network dies instantly. To finish our topology talk, we have three other shapes. First, ring topology, where computers are connected in a circle, like children passing a ball around in game. The data moves in one direction to prevent data collisions. Second is mesh topology. This is a super safe but very expensive layout because every single computer has a direct cable to every other computer in the room. It is used by the military or bank servers because their network must never disconnect. And third is tree topology, which looks like a branching tree. It connects multiple star networks together, making it perfect for a school or campus building with multiple floors, like floor 1, floor 2, and floor 3. Computer network help organizations work efficiently by sharing resources, enabling instant communication, and securing data centrally. They scale from local rooms or LAN and cities or MAN to global connection, WAN or Internet, operating via client server or peer-to-peer setups. To connect properly, they rely on key hardware like NICs, switches, and routers, which are organized into layout like star, ring, or mesh topologies. And next, reflections. This material makes us realize that computer networks is not just about cables and hardware, but a vital foundation for building digital spaces and connecting people. The use of visual and small details in topology examples clearly help us understand how networks work much more easily. This reminds us that careful network planning is the ultimate key to creating modern communication systems that are fast, secure, and reliable. That brings me to the end of my presentation. Thank you very much for your time and attention. Thank you.